From sand to clean energy, how are solar panels made? Here, in the heart of Chinese industrial cities, sand is not trodden underfoot, but miracles are made from it. 22 solar panels every second. China does not just make panels. China is building an artificial sun on Earth. From simple silicon granules to energy that lights up continents. Today, we break into the secrets of the sand revolution. Are you ready to see the impossible? The sand that makes the future. The story begins here, from quartz sand. But beware, a single impure grain of sand could destroy an entire factory. The factory here does not accept 90% or even 99%. They are chasing the impossible number, 99.9%. Why this obsession? Because just one microscopic impurity means the loss of energy and the complete destruction of the cell. Converting sand to this purity is harder and more complex than refining gold itself. At a temperature of 1400 degrees Celsius, the sand melts to become liquid lava. For this reason, we use graphite-covered furnaces that rise to 3 stories. Here, solid silicon turns into a fiery liquid. Then the miracle begins, crystal pulling. A small seed crystal is dipped into the liquid, and it is pulled very slowly, 1 millimeter per minute, as if we are extracting the soul of silicon from the fire. It is like a game of tug-of-war with nature. The result? A giant silicon ingot weighing 800 kilograms of pure purity. Silicon is the second most abundant element in the Earth's crust, but converting it to electronic purity is harder than refining gold. From ingot to wafer. How do you cut the hardest material in nature? With diamonds. Wires covered with industrial diamond dust, moving at a speed of 40 meters per second. Imagine, these wires cut silicon into wafers thinner than a hair on your head. Each single ingot produces thousands of wafers. The thickness of each wafer, less than 200 microns, while a human hair is 70 microns. And this precision is what makes the cell capture light from all directions. Here there is no room for error. Physics of light, cleaning and polishing wafers. After cutting, the wafer surface has become rough and needs high-precision chemical cleaning. The wafers pass through consecutive tanks, purified water, acids, alkalis, then precision mechanical polishing. Why all this? Because an irregular surface means scattered light and wasted energy, and energy loss here is forbidden. Birth of the cell, the heart of the panel. Here, a physics enters the line. The ordinary wafer does not generate electricity yet. It needs to be coated with phosphorus and boron in diffusion furnaces at a temperature of 900 degrees Celsius. Why these 2 elements in particular? Because silicon is neutral. Phosphorus adds extra electrons. Boron creates gaps. And when the electron-rich region meets the electron-poor region, an electric field is created. In short, we make a giant solar battery from a silicon sandwich. This technology is called passivated emitter and rear cell (PERC) or TOPCon, and this is what raised the efficiency of panels from 15% a decade ago to more than 25% today. But stop! Before we continue, how does this chemical sandwich turn into electricity just by touching light? Let's open the cell and see the magic. How do solar cells generate electricity from light? Before we continue, let's reveal a mystery that many get wrong. Solar panels do not absorb the heat of the sun. They do not care about heat at all, but rather they love light. Let's open the cell and see. Imagine the cell as a 2-layer sandwich. The top layer is crowded with extra electrons, and the bottom layer is full of gaps waiting for residents. And between them is an invisible wall that prevents crossing. When the sun shines, it sends armies of photons. A photon has no mass, but it possesses enormous energy. As soon as it hits an electron in the top layer, it forcefully knocks it out of its place. The displaced electron wants to return home, but the wall prevents it. Here we trick the electron. We make an external path for it, a copper wire to return, and when millions of electrons run through this wire to reach the other side, congratulations, you have obtained an electric current. This running is what charges your phone and lights up your home. And the surprise? Panels hate summer. High heat makes the electrons lazy and reduces efficiency. Solar panels work at their best on sunny and cold days. Now, after we know how light generates electricity, we return to the heart of the factory to see how these silver veins are printed. Electrode printing, veins of the cell. The cell is ready, but the electrons do not know where to go. Here, the electrodes are printed, the veins of the cell. Using a paste of pure silver, the best conductor on Earth, we print lines thinner than a spider's web, measuring 30 microns. The robots here work with surgical precision. 3,000 cells per hour. No human can keep up with this terrifying Chinese rhythm. Are we finished with a single cell? No. Now comes the biggest challenge. Assembly, from cells to panel. Welcome to the heart of automation. Here we connect 60 or 72 cells in a single electrical series. Each cell is connected to the other with soldering ribbons. The robots do it at a speed of 3,000 cells per hour, with surgical precision. No human can keep up with this terrifying Chinese rhythm. We did not belittle humans, but in today's factories, the human here is only the supervisor. The robots, sensors, and algorithms build the panel before your eyes. Lamination, locking the cells forever. The panel is now ready, but will it withstand desert storms? Here comes this moment of truth. The cells are now arranged, soldered, and tested, but they are naked. They need protection for 25 years on a house roof. Here the 3 layers enter: tempered glass from the top, the EVA layer in the middle, and the composite backsheet from the bottom. We put all this in a lamination oven, 150 degrees Celsius, under complete vacuum. The result? One solid panel, resistant to water, dust, and UV rays to last 30 years, without losing 80% of its efficiency. The battle of quality. Before any panel leaves this factory, we face it with an artificial sun. The flash tester device releases a light flash equivalent to 1,000 watts per square meter. In a fraction of a second, we calculate current, voltage, power, and efficiency. Any panel that deviates by 1% from the specifications is rejected immediately. After that, an electrical insulation test at 3,000 volts. Finally, spraying water on the panel, simulating a tropical storm. China now produces 80% of the world's solar cells, not just because they are the cheapest, but because they are the most successful in passing these tests. Where is the industry heading? One factory in China produces 10 gigawatts annually, panels sufficient for 2 million homes. But this industry faces a challenge. What happens after 25 years? In 2026, China issued new legislation demanding the recovery of 250,000 tons of expired panels by 2027. The goal: advanced dismantling technologies and the extraction of silver, silicon, and glass for reuse. Some see the old panels as a mine. Others warn 80 million tons of waste by 2050. The question is not, will we make better panels? The question is, how do we make them forever? Imagine powerful energy flowing in absolute silence. No engine noise, no fuel burning, and not a single mechanical movement. It is the miracle inherent in grains of sand. When they meet the threads of the sun. From the sand the story began, and to the sand it will one day return to be reborn. This is the cycle of life in the world of major industry, purity extracted from the heart of nature, to light up the future of humanity. And now, tell us in the comments, do you think the sun alone is enough to power our planet? Or will we remain hostages to traditional sources? We read all your opinions. If today's journey amazed you, don't forget to join our family by subscribing and activating the bell. Share the video to spread knowledge, and wait for us for the next factory hide secrets beyond imagination.